Attention, please.
So, let's welcome Andrey with applause.
So, hi everyone. Today I'd like to tell you about one way on how we can define our Kubernetes cluster behavior profile and alert if something is wrong with it, right? So, some disclaimer maybe, we hear DevOps party, or I hear VCDL party, right? Yep. Some of these things could be applied not only to Kubernetes environments, but also to other environments like Docker, like anyone is running Docker Swarm here? No one? Kubernetes.lv? Oh, you, all right. So, one guy, please, that's great. So, yeah, and these things could be applied also even to non-container environment, literally to anything that's running on Linux, right? So, my name is Andrey, and my background is coming from the startup world where scaling, stability, performance things really matters, and like everyone knows that startups can explode sometime and grow faster than you can actually fix different technical problems, right? And one of the famous startups I worked with had a really great opportunity in our Latvian one called Ask.fm. Hi, Valera, Yura. Yeah, so, yeah. And nowadays, enterprises woke up and also want all these fancy, modern DevOps things, right? And they also don't want to feel anymore behind IT industry. And I decided to myself to open that whole new world of enterprise IT and deliver like all these modern, fancy DevOps solutions there. So, at least comparing to startups, I don't have to be on call anymore, right? So anyone is on call here today? Good for you, man. So, well, and now I work with an awesome and really experienced team in Ahead's company. So, our main expertise area is in fintech, payments, banking, crypto. So we do write stuff in Java, we know cloud, microservices, we adopt like DevOps practices to companies, and we master test automation. So you can see that we are slowly growing, like we were 8, but actually we're 10 already. So if you want all these great things, we are really want to help you. So feel free to reach us. Okay, so one of the projects that I work currently is actually a payment system, and because we are processing payment cards, right? So we need to build a compliant with payment card industry data security standards infrastructure, which shortly sounds like PCI DSS, right? So the auditors, before giving a compliance certificate, will ask you a lot of security questions, and a few of them are: how will you know if you've been hacked or something changed in your system? So we had to find something for Kubernetes in order to be sure that we are fine in terms of security, right? So Kubernetes security. So in order to be secure with Kubernetes, we have, of course, to use firewalls, or firewall maybe, outside of our Kubernetes cluster scope, that controls the traffic that goes outside of our Kubernetes cluster to internet or coming inside our services, right? So then we have for sure to use network policies inside Kubernetes cluster to control the traffic between pods, because actually, by the way, all network connectivity between pods in Kubernetes cluster is allowed if you don't apply like network policies, right? So also we have to use pod security policies to not allow Kubernetes to launch like containers, for instance, with access to host network, or like to mount them host directories in container that actually don't allow to do this. And for sure we have to think about proper role-based access control. For instance, do not give to our CI/CD system access to all deployments that we run in Kubernetes, but restrict like it to only a single deployment, not to config maps and stuff like this. Also, we have to restrict our users of Kubernetes cluster, like our developers, not allow them to do like everything, like don't give them admin access to everything, right? Excuse me. So yeah, and we also have to restrict our kubelets to not allow them to download like images from internet, from hub.docker.com, like everyone likes to run some PHP from public repository, right? So, but sometimes shit happens, even if we have like all these things in place. Like for instance, some network administrator, Vasily, decided to test new exciting his firewall feature and by mistake opened like some of our services to public and then went to vacation, right? And they remained open like for 2 weeks and no one knows about it, right? Or for instance, some developer, no, I mean, that's not actually funny, that's the case in our, that's a thing in our case, because for instance, with the project that I currently work with, so network administrators decided that actually it is totally fine to allow outgoing connections to all Microsoft Azure services from our cluster. So literally they just downloaded an IP range of Azure stuff and then applied to firewall and good to go, right? So I personally don't like such approach. So we have additionally network policies in our cluster, like to not allow like our pods to communicate with everything, but only with specific resources that we want to, right? So then maybe some developer one day decided to use a new fancy library. Yeah, so he added to his like code, then pushed it to master, like CI system, compiled it, everything is fine. Then CI tested like that his new image, Docker image, in terms of security, and it appeared that library had 0-day vulnerability that no one knows. And CI system told that everything is okay, and we uploaded to our trusted images repository, then deployed to production, and everyone is happy, right? So until some point, right? So, and we want to know about this shit that can happen as soon as possible in order to fix it or mitigate it before like real damage to business happens. Luckily, there is a great way to define what is okay and not okay. So meet Falco. That's the thing that we're going to talk about today. Is anyone here heard about Falco before? You? One guy. Awesome. Awesome. So, then it means that I don't have to finish again to talk a bit more about it. So, what is Falco? Falco, this is a behavioral activity monitoring tool that can detect suspicious activity defined by a set of rules. Interesting, isn't it? No? So that's all more about it. So before jumping into guts of Falco, let's talk a bit about sysdig tool, which actually is a core of a Falco. So anyone knows what sysdig tool is? Same. Ah, 3 guys. Awesome, 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 awesome. Just getting more popular. Right, so sysdig is actually a tool, libraries, and a kernel module that actually sits right there, yeah, between kernel space and user space, and captures the system calls defined by sysdig expressions, right? So anyway, let's not go deep today into technical details, but simply you can think about sysdig like a TCP dump, but not only for network traffic, but also for system calls, right? So what is a system call? Like, it's really simple, like reading file is a system call, writing file, deleting file, spawning a process, killing a process, privilege escalation, initiating network connection, and blah, blah, blah. So there are currently around 300 different kind of system calls in Linux kernel, right? So, and the killer feature about sysdig, that it can give you a context of these system calls. So you can know what exactly emitted that system call, right? So it's really exciting, even if you don't run Kubernetes. So you can use sysdig like anywhere on Linux, right? So, and the most exciting feature that sysdig was made with containers in mind. So it means actually that it can enrich the context by talking to Docker daemon or Kubernetes API, or like at the same time to both, like to actually enrich your context, like with some container metadata or Kubernetes metadata. So you can actually know from what container and like pod name, namespace name was emitted, like particular system call, right? That's really amazing. And same applies to network activity. You can know like the network activity of your particular process or like Docker container, like, yeah. So also there is a UI tool that comes with sysdig. It is called sysdig. It looks like this, right? So I really recommend to play with these tools, as they can replace you well-known tools like TCP dump, top, strace, what else? That's that. LSOF maybe? Yes, yes. LSOF definitely too. So, and of course, like sysdig and sysdig are container aware compared to these classical tools. So here are links that you can actually check different sysdig examples, like what kind of magic sysdig can do for you, right? And let's get back about to Falco, right? And Falco is actually an application where you can define all these sysdig rules and alert based on them, right? Is it clear? Mm-hmm. All right. So let's take a look at the architecture of Falco. So here we can see like the kernel part, that kernel module actually that captures all these system calls. So you define Falco rules, then actually in short these sysdig libraries do compile micro programs based upon your rules, and then these micro programs are getting executed right in kernel, and then when something matches, it passes like the matching event here to sysdig libraries, which are then enriching the context by talking to Docker and stuff like this, and then it passes like all these matched things with enriched context and with defined output message, you will see it later, to a different Falco outputs. And Falco currently is able to send messages, alerts to different outputs, like syslog, or writing just a simple file with like alerts to your disk, or just print them to standard output, or like pass that message as the argument to some shell program that can like react somehow on these messages and do some real actions. And there is one more output, but it's not there on the slide because I didn't find anything better to steal from SysDeke's presentations, right? So this is a HTTP output, which actually can send these Falco alerts as JSON to some HTTP URL, and behind that URL can be located some service that will do some job, right, with these alerts. Okay, so and recent versions of Falco started to support Kubernetes audit events as an input source. So, but let's cover these Kubernetes audit events a bit later. So, let's take a look at an example of Falco rule. You can see it looks like YAML, right? So, well, I'm not there. So in Falco, like we can define a list of something. So here is the shell binary list, which actually like contains all well-known popular shell binaries, right? So we can like use these lists to not define like all binaries each time in each rule. So then Falco have macroses, so we can create some Falco condition and then reuse it later in different rules. Like this one actually matches the process name, like anything from that list. So we will catch some process with the name. And then macro with a container that matches that the source, like the event should be like initiated not from host but from container, right? So that equals host. And this is the rule itself. So we have a name there, like terminal shell in container, a description, what is that rule about, and the condition that actually reuses these macroses. So it's really, really human readable and easy to understand. Like container, like event should be from container, and the process name should like be one of these things. And then we define an output actually, like some message, and you can see here in braces, or brackets, how it's like this, I don't remember. So you can enrich the message output with actually some metadata, some fields, like we can catch like what Linux username run a shell binary, for what container, and like different things. Like there are so much like such kind of fields that you can use to enrich your alert. So I really recommend to go and just check the Falco's documentation to take a look at a list, and it's like really big, impressive list. So, well, that may look like, oh man, like I have to define like so much things, like in order to define my like infrastructure system behavior, right? But luckily, on Falco's GitHub repository, there is ready to use like filter default set of rules that actually covers most of everyone's needs. And I really recommend also to check this default rule set because at least it's really interesting to know and discover for yourself like what kind of things actually you can monitor in terms of behavior. Like it can be new openings for you, right? Like about things that you never thought before. That's amazing. So what else? Yeah, and you can just take this default rule set and just run Falco without any changes and see like immediately what it can capture for you, like run it on production. These filters are actually non-blocking. They are asynchronous and just literally add few nanoseconds of overhead. So it won't ruin your production unless you actually decide to like match all system calls over some regex or a string. So just don't do stupid things and everything will be fine, right? So this is how can look an alert message from Falco, and it was really interesting to find out about one thing. So we run, the Falco is working currently on Kubernetes cluster, which is managed by Microsoft Azure, right? So, so it was interesting to find out that there is one critical service called tunnel front that's actually really, really badly documented on Microsoft website. I would say I just found some info on GitHub issues, not on like official documentation. But it appeared that this piece of software actually keeping an SSH connection from your Kubernetes nodes that run in the private network to the Kubernetes master that runs somewhere in Azure services, but definitely not in your network. So they use SSH actually for communicating such commands like kubectl logs when you want to like fetch them to your laptop, or like kubectl exec, right? So, and we can see actually there that this piece of software actually rotating SSH key, at least they rotate, and that's good, like thumbs up for Microsoft, right? So, and we actually see the context, one more context, that some copy command was actually not invoked directly, but from some parent, and this is some shell script. And the bad thing that you actually can't do anything with this tunnel front. It works as it is. You can change settings there. You have to live with what you have, but at least you know like how your system actually works, and that's great, right? So, what next? One more real-life example of where Falco helped us. So the auditors actually wanted from us a procedure when someone changes firewall rules, our cardholder data environment, which consists actually from Vault and the Postgres database, they wouldn't be able to connect anywhere to internet. So somehow we should check it, like running some ping script like on these spots as a sidecar and alert if something is bad. So instead of this, we proposed Falco rule that actually matches Vault, Postgres, Vault like database for Postgres, Kubernetes API servers, some macroses that are actually matching when something tries to connect to API server or API server IP over HTTPS port. Same for Postgres, like IP address and the port. And then we match Vault pods. So we match like pods that start with name Vault. So we have a stateful set of 3 pods. So and they do work in namespace called Vault also. So and then the rule itself. So the condition looks again like really easy and human readable. It's easy to understand. So the outbound, that's macros actually from default rule set that matches like outgoing connections to somewhere. So outgoing connection and from container and from Vault pod and not to Kubernetes API server or Vault Postgres SQL database. So in case it is matched, in case like Vault pod will try to communicate somewhere else, we will get notified immediately. That's awesome, right? So I told before about that Falco recently started to support Kubernetes audit events, right? So as we know, all communication with Kubernetes is done through the Kubernetes API, right? So, and luckily, all these calls to Kubernetes API could be logged. Like, we can know who, we can know when, we can know where and what, and even was it successful attempt or not. So we can log all these things, right? So Kubernetes audit currently support 2 types of backends. Oh, sorry, I missed. Like, if you want to know more about like Kubernetes auditing, just go to official documentation. It's all there. Sorry. Yeah. So Kubernetes audit supports 2 kinds of backends. So the first one is a log backend, which actually logs all like Kubernetes calls to the file on the disk. And that's not what we want with Falco. And the second one is a webhook backend that can send all these Kubernetes audit like events as a JSON to some HTTP URL. And actually Falco has a web server inside that can accept these Kubernetes audit JSON events and then evaluate over the expressions that you define in Falco, right? So let's take a look at them at another example, right? So here we're detecting a case when some developer tries to create a new deployment on Friday at 6 p.m. So say it's so easy to understand some Kubernetes activity with action create and destination deployment, and it was successful, right? And so we here again we enrich the output message with Kubernetes metadata, so we can know who created deployment, what the deployment name, and in what namespace. Again, you can just go to Kubernetes, Falco documentation and see what kind of fields you can put there. The thing only that you can't mix the system call like fields and the fields that are only for Kubernetes auditing. So separate thing, but at least you can go to the guy and tell him that you better go to take some beer, like instead of deploying some interesting service on Friday, right? So another example, this is a security rule, so it detects and attempts when you, when someone, not you, when someone wants to bind a default cluster admin Kubernetes role to all namespaces, right? So that's definitely suspicious if something tries to do that action. So, and we really want to know about it, right? So, what else? So, okay. So we defined all these system calls rules. We defined all these Kubernetes audit event rules, and they are producing some output when we match it. So what we can do with all these outputs? So we can at first simply send them to our logging system, and to my surprise, like I'm not an enterprise guy, but to my surprise it was interesting to know that enterprises do have separate security teams that actually love to receive all logs, events from all the sources, right, and do something with them, right? I personally don't actually know what do they do with that information, but definitely something good, right? So yeah, and what else? So in my case, I just simply pointed the old Falco there to Slack, then left it for some days, and then just observed what Falco captures over that time, and then fine-tune the rules, and we are good to go. So after like some time, you defined all rules of your Kubernetes cluster profile, behavior. You know how it works. You have a confidence. You can actually think of different severities, like what is really critical, what can wait, and after like you defined all the things, you can send these alerts not only to logging system and security teams, but actually to some system that can do real actions based on these alerts. right? And here are some ideas of actions, like what we can do with Falco in case something suspicious happens. Like we can kill a pod when it behaves like oddly, right? In terms of security, we can taint a node, like to not allow Kubernetes to schedule more pods to it. We can drain a node to remove like everything out of the node, or more interesting that we can apply network security policy. Actually, instead of killing pod, we can later then just exec into that pod and see what attacker actually wanted to do with our pod, like how he got into it and stuff like this. At least get some information and find something new for himself, right? That's interesting. Or simply we can bring whole server or /service down, because it's better to be down than hacked, right? Especially in enterprises, I think. Or we can simply call, not we, but Falco can call the police, because actually that's not our job to fight criminals and other bad guys, right? So, as an example of an action system, so as an example of an action system, there is one thing made also by Falco guys, this is the guys, which is called Kubernetes Response Engine. That actually piece of software looks more like a proof of concept than a really working solution, but at least the idea behind it is really great. So shortly and really fast, like we have a Falco running there that captures some events, things that we define, and then it like matches something. It sends it to Falco NAS sidecar, which actually parses an alert, takes the severity, then publishes it to some severity topic to the NAS message broker, which actually then, not it, but then we have a kubeless running in Kubernetes cluster. This is kind of like AWS Lambda, but running right in your cluster. So it has native support of NAS message broker, so it subscribes different functions that do real actions to different topics, and when something like comes into there, like kubeless can invoke some function and do like real action, like calling the police, for instance, right? So that's pretty it. Let's have some demo if we have time. Like really short one, quick demo. Okay. I will try to. Let's hope it will work. Can I actually mirror a display? Oh, what is that? No one should see that. Okay, so I have Falco running in my Minikube installation. So
can we do it on production?
Huh?
Can we do it on production?
I just come and show you the production. If I were working with startups, then no problem. I'm an enterprise guy, so sorry. Right? So let's see what we have in Falco logs. So yeah, so we can see there that it tried first to compile the kernel module, but it failed. Well, so after that it tried to download the precompiled one from sysdix repository, and it was successful, I guess. So let's try to see it in action and see if it really works. So I have an old exporter there, the Prometheus one. I think everyone should know this piece of software, right? So, and literally we have there like simple daemon set. ESP is a pod security policy, and the service and some service account. You have to use service account if you want to bind your daemon set and pods to the pod security policy. So let's just simply apply them and see how Falco will react. So much messages. So these are default settings. It's not filtered like things like this. So we see some messages from Kubernetes, like audit events, like daemon set was created. So we can send this alert or log message and know when something changes in our system, right? So same for other resources that we made there, right? Like a cluster role created, and we see that there is also a warning that pod was started with sensitive mount, like with sys on host and prods. Of course, we know that Prometheus just need these things in order to collect metrics, right? So when we do it on production, we of course will exclude like all these things to not like send all this garbage, right? But that's a demo. The purpose to show garbage, right? That it can make garbage, right? Then we can filter it out. Okay, so service account, blah blah blah, some duplicates, I don't really like. So okay, so let's try to execute some commands. The pod, you see how the Falco behaves. Right, so we have Prometheus, right? So let's run something like this. No reaction. Maybe let's wait. Oh, did you see that? Notice attached to the pod, like user, the pod name, the namespace. That's what I showed you in examples, and the action exactly called yes. So now let's try to run some bash. That's what hackers do, right? No luck. I don't have bash. Maybe let's try to copy some file. Like bin ls bin follow. Permission denied, but at least we have a message that someone tried. Like nobody, user nobody. That's like Prometheus running with user nobody. So and we see that file below no binary directory renamed or removed. That's awesome, right? So the bash didn't work. Maybe let's try with sh, like simpler one, and see what happens. Interesting. Oh no, we've been out. Thank you. That's pretty it. So that was a Falco like in action, right? So sorry, you can see my text there. Okay, what we have.
Can you enter inside Falco container? Can you enter inside Falco container?
Of course.
And you want to write.
Let's do it. Can you see? No? Let's do it. Why not? This is Falco. I'm not cheating. So, get pods, so we have Falco. Blank screen. Bash. Oh no. No cheating. All true. All right. So, where is my presentation? Yay. So, demo. Yeah, it should be demo there. Okay, so what we have learned today is that Falco has a really, really great potential and adds one more way to monitor your system, right? And I would really want to know, how do you monitor intrusions to your clusters? Thank you. Questions, please.
Is it, Falco can be deployed in virtual machines as well, right? Like, it does not depend on only Kubernetes.
No, as I told, it can be used on any Linux machine.
Yep.
Like?
Yeah, and is there any minimum kernel version?
Well, as far as I remember, if you have some not really, really recent versions of kernel, so there is a kernel module made by sysdig that works with older ones, and currently Falco is looking towards moving to the upstream kernel module called eBPF, right? So so they are slowly dropping their old like module in favor of that native kernel one, like the upstream, right? Yeah. So yeah, it can be used on older systems too.
Yeah.
Yeah. Yeah.
Thank you.
More questions? Yes, please.
Can it look into network traffic?
Yes, of course, and you can know what actually.
Like what is being sent over, if it's not encrypted?
Yes, exactly. Encrypted? No, of
Or like
course.
HTTPS at one.
No. It's not about encryption. So in terms of to decrypt traffic, you you have to somehow pass it through your decryption key.
Have
But
to have
sysdig,
certs.
yeah, so no, you can see the traffic, you can see where communicates with your specific process or container or pod, like every single connection attempt, like each packet sent, so which actually matches to a system call, right? Yeah, but it has like nothing common with HTTPS sniffing. Right. Yes.
Yeah, I have a question. So, sysdig is monitoring process on Linux, container is also process on Linux, and so that's why we can see all the system calls, etc. And this is a process which is running under root usually. To sniff all the syscalls, right?
I'm not sure about root, so actually sniffing happens in the kernel module, not in the process. So I'm not sure that root is required. As far as I know, actually don't remember, so I'm not sure. Like maybe you don't need even root.
Okay.
Yeah.
But so you also showed example of running it in the Kubernetes.
Yeah.
But if it's not bare metal, you don't have access to your host system, so you're running sysdig in a separate container, in a pod, or dynasty. How many accesses to the host system sysdig needs?
What kind of access you mean?
So basically, I think you need to mount something inside sysdig, like for example some Linux files, so you can read through and tell you that something is happening.
Okay, I will repeat it again. So sysdig uses a kernel module, so you have it to be loaded into the kernel. If you don't have it, you will not be able to send like any micro programs that will catch some system calls. So you don't need to mount like anything.
Yeah, but isn't it limited like with a namespace? So that potentially means that I can launch any other process and monitor the same thing as Falco does.
I don't get. It works on the kernel level, so kernel has access to all namespaces.
Yeah, but
It enriches. Oh, okay, yeah. So talking about enriching the context, it has to have access to Docker socket
Only.
and Kubernetes API.
But it's working with system calls.
It
right?
works with
APIs.
System calls are not having the container context. So if you want like to find like from what container.
Okay, maybe I get the question.
Okay.
So we have a nasty admin on bare metal, and he wouldn't give us access, but he gives us Kubernetes with full admin control. Can we install sysdig?
Okay, there is one example. For instance, Google Cloud, Google Kubernetes engine uses a so-called container OS, which actually limits you access to kernel. Right? So, but sysdig and Falco do work there because the kernel has the compile in that eBPF module, like the upstream one. And as I told, like sysdig is moving to eBPF, so it can talk to the eBPF kernel.
So this
module.
eBPF is something standard, like
Yes.
syslogs, something like that.
It's standard kernel, the part of the kernel part. Yeah. Oops, sorry. Yeah. So actually, if you don't have access to kernel, you have to have, of course, loaded kernel. First of all, to ask your sysadmin to like compile me that kernel module from sysdig and have it loaded everywhere. Then we can use sysdig, right? And yeah, if we don't have such option, like to compile like some third-party modules into kernel, as I told, there is eBPF, but it is supported since like 4.14, if I'm not wrong. right? So Falco also can use the eBPF native module for the same job, right? Does it somehow answer your question or not? Okay, okay. Yes, please.
About Falco and PCI DSS, you use it for like EDS?
Yes, exactly. That's our intrusion detection system. Yeah.
Only Falco. It's normal for all yes.
For firewall as well, we have some.
We have firewalls that do
Yeah,
also
yeah, of course.
traffic.
It's about IDS.
That's one additional like layer of security. Like auditors like don't really like containers and Kubernetes, right? So we have like such good thing to show to them. Yes.
Additional question regarding the audit and the audit stuff. If it's running in the cloud, usually cloud providers already have some logging or auditing things. Why this is used?
Why this
when,
is?
when is the case? So you have the case when you're running Kubernetes on the bare metal?
No, in the cloud. So the thing that I was talking not only about Kubernetes audit events, like if someone, for instance, let's say we had a case when someone decided to mine some bitcoins, right, on our servers. Yeah, and we just found it like a few days later, right? So Falco would definitely detect this. Yeah.
Maybe.
Maybe, like if we properly define rules, right? Yeah.
You need to run it in privileged mode to allow it to load these microprograms to eBPF kernel, so it should communicate it somehow.
That guy is already asked that question, so I'm not sure. It uses kernel module, so theoretically it doesn't need to have root access. It has to have access to Docker sockets, like to unleash the context. I'm not sure. I will not 100%.
One more question. Does it have some, let's say, HTTP health check? Because you need to make sure that it runs all the time, that it's available, because it's kind of Kubernetes deployment or stuff like that, and you need to make sure that it has health checks. But if you have either HTTP health check, either TCP socket health check, or you can run a script. But if you allow to run a script inside your container, then you should make sure that this is right kind of script, because it's execs and stuff like that.
So,
what's your strategy to make sure that it runs? Because if it's silent, it's either everything is okay, or either it's dead already, it's dead, and so.
Yeah, so that's a good question, because actually we didn't implement such health check, right? So we have a health check for our logging chain, if we don't receive a heartbeat message, we will alert that our logging is down, so we can implement the same for Falco to generate some events. And if we, with a proper severity, severity health check, right? And if we don't have it, got it in 5 minutes, then we alert that something is down. We have Prometheus monitoring that, monitor that all daemon sets are up and running and stuff like this. Yeah, but of course, I think that's a good idea to implement such kind of health check. Yeah. Yes, please.
I have another question. When you showed the demo, when you just started container with the sysdig, you started to download files from the internet. Compiled them inside and then started to run. Is it default behavior? Because we're kind of talking in the context of security currently.
Yeah.
It's downloading something from somewhere.
So that's the default behavior exactly. Yeah, but I don't have Minikube thing, so I don't have these kernel modules run in my VM. But in case of if we run it in some secure environment, we can preload this kernel module by ourselves, And as I told, we can use a more modern kernel that has eBPF, and instead of these sysdig module that was downloaded from internet, we can use eBPF, that's already there, right? And as I remember, there is environment variable for Falco. When you start it, you can skip that attempt to download something. Yep. But yeah, last question.
How do you analyze the slopes? I mean, like, if you have a big infrastructure,
Yeah.
it could be really messy or spammy.
We simply hire a security team, as I showed that lab to dig and all that great.
No, I mean, of course, they like, but like, do you know any solution to how to, I don't know, make probably another layer on top of that?
Okay, so you're talking about machine learning,
Yes.
right? Yeah. So yes, of course, yesterday we wrote a machine learning solution, but I'm just kidding. There are solutions for money that you can buy. That's kind of like was a poor man solution, open source and free. So as far as I know, there is a twist lock that costs some money, and it can do like all these, like automatic your system behavior, like can analyze automatically, define rules automatically, right, and then alerts if something bad. So they use machine learning. So we are poor, we use Falco instead of twist lock. Thank you.